All right, good evening, everyone. So these are the submitted questions via email for tutoring. So all these questions are coming from on Calculus. So let's go through these. So 56, 60, 64 have to deal with finding the domain of the function. So as stated in the previous videos, um, we we asked the question of finding the domain. We're asking about what number are you allowed to plug in? Which is a pretty big open ended question. So, to answer that, the best way to respond is by looking at, well, what numbers can't I put in? Because whatever numbers you can't put in, you can just erase that from all the numbers that exist. So, we can simply state, hey, the domain is everything except for these numbers. That's much easier than saying the domain is all these numbers. So, we always start by default saying the domain numbers, and then we'll put an exception, except following numbers in case there are some numbers that do not work. So in my previous videos, I had stated there are really two types of functions you want to look out for, or two types of operations you want to look out for that will usually indicate that you have restriction in the domain. So one of them is anytime you see division, and then the second one is whenever you see radicals, specifically even roots, stuff like square root, etc. Even root. Okay, so with division, why we look out for that is because we cannot divide by zero. Radicals, we can't have negative numbers inside of an even radical because we would have imaginary numbers. So 56 and 60, let's look at those. So starting with 56, am I doing any sort of division? No, I don't see any division happen. Is there anything involving radicals? Any even roots? 56. No. Second power, but that's not a radical. So nothing here seems to trigger any warning lights or bells. So I'm going to just say the domain is all real numbers. Things should work. There isn't a number that I can think of that if I were to plug it in, not going to give me an answer. All right, so we get to 60. Let's look there. Again, I'm going to default by saying, okay, the domain is all real numbers, but are there any exceptions or things that I want to take out? So again, is there any division happening in this problem? No, I don't see any division. Is there any even radical in the problem? Okay, there is an even radical. It's a 4 root. So remember, I can't have any negatives inside the radical. So now we're going to check. So that means this that's inside the radical cannot be negative. If it's negative, I got to take those numbers out. So when is x squared plus 3x? When is that going to be less than 0? If it's negative, I don't want to include those numbers. I'm going to say all real numbers except for. So I'm going to go ahead and solve quality of this. So that means x. So when is this going to be 0 is when x is 0 or negative 3. That's when this would be 0. So now the question is, draw a little number line, demonstrate negative. Here's my little number. So now I want to test, where would this be negative? Will it ever be? So let's try numbers bigger than 1. Sorry, numbers bigger than 0. So for example, if I plug in 1, I'm going to get 1 plus 3, which is, if I plug in 1 into, is that less than? So does that work? No. 1 plus 3 is 4. 4 is greater than. So no, I would not. Those numbers would not cause an issue. What about numbers less than 0 but greater than -3? So what if I plugged in a negative? -1 squared would be +1, but -1 times 3 would be a -3. So is this less than 0? Yes, that is true. So all the numbers from here to here, I tried a number in here, is in fact going to give me less than 0. So if I were to plug in -1 in here, that wouldn't work. It would yield a negative number. Root and even roots cannot have negative numbers inside of them. All these numbers in here don't. All right, now what about numbers less than -3? What if we did -4? -4 squared would be 15. -3 would be 12. Negative. So this again is false. 4 is not less than 0. So these numbers in here are going to make this expression less than 0. So we don't want to include. I'm going to come here and I'm going to say it's all numbers except for numbers between -3. So all numbers except for those numbers. Can't have those. Okay, if we use those numbers, that's going to cause an error. That's going to make us get a negative. All right, let's look at 64. Now 64 is actually the more complicated one because both things are happening. So first is there is division happening in the problem. Okay, so I got to deal with that first. Let me go ahead. I'm going to space. Try again. Set this here. I move this space. There we go. All right, so first I'm going to deal with the division. So I cannot divide by 0. So meaning I look at the denominator. What value of x would make the denominator 0? And that is -6. I'm going to write it over here. So at -6, denominator would be 0. It's not going to work for us. So I cannot. So I'm going to start writing my domain. All except for x6. So that deals with the division. Okay. Right over here in blue. So I remember, why am I writing this? The division part, not b. -6. Now, do I have any radicals in the problem? Yes, I do. It's up here in the numerator. So this inside the numerator, x plus 6, cannot be less than 0 because it's negative, root of a negative, and that's imaginary, and I cannot have that. So when is this going to be 0? That's a simple one to solve. 6 over. So x less than -6. Any numbers less than -6 is going to cause a problem too. So I'm going to add some more to this. All numbers except for x being equal to -6 or x less than -6. That's my domain. Now we could write this a little nicer because it's this and this and they happen to both be the same number. So I can just say, instead of equals or less than, how about I just put it all together, say x less than equal to. That covers both issues. My radical. So in short, I look at my functions and I check division happening, there are radicals happening. Those two things are not happening, like we saw with number 56, no real number. If any of those two things are happening, then I have to add in my exceptions. Oh, it's all numbers except for these. And I cut out the exceptions. Okay, so that's how we find. Now let's look at 84 and 6. 84, we had to simplify the expression. So I actually did this one earlier today in one of the classes. I'll say it was period B. So if are in period B, sorry, not period, period C. Still getting this was done in period, and so if you were in that period, you can look at the video for today and you can see how that was done. So we want to set up and then clean up. So with 84, first thing I want to do is set up. So meaning I'm going to substitute in those expressions for x, for f of x, and for f of x plus h. So f of x, I already know. Give that to me. That over here. Then I have this guy here, f of x plus h. What is that? I don't have that. I have f of x. Remember that that x is just a placeholder. Don't get hung up on the letter. I'm going to write the function like this. Hopefully it makes it a little bit easier to understand. That x is a placeholder. It is a blank. So whatever we stick in here, you stick the same thing in each of the other slots. So when we do numbers like, oh, f of 2, oh, it's 2 cubed plus 2. Okay. What about f of triangle? Oh, it's triangle cubed plus triangle. You don't care what you put in. So now what happens? Oh, f of x plus h. What is it going to be? Plus h cubed plus h. There you go. And that's exactly what we're going to substitute here. Say x plus h plus there. So all this, my f of x plus h, minus my f of that dividing by h. Here's my substitution. That's my setup part. Now it's time to. Now we're going to simplify. So we're going to expand some stuff, like terms, try to simplify where we can. Want to show our steps. This is important. Don't show your steps. Just didn't show this setup. This is the correct setup. If after this I mess up expanding, I mess up in collecting like terms, you at least get partial credit. This is why you want to show your steps. Don't show your steps. I cannot give you partial credit because I don't know where you got that answer from. Okay, I don't see where you made a mistake. I just see a wrong answer, no work, get nothing. Make sure you show your steps. All right, so I'm going to start by expanding this here, so x plus h cubed. So go off to the side to remind you, how do you do that? So in case you some algebra review, x plus h times x plus h plus h. Multiply these together first. X squared plus 2xh plus h. Now I have to do it again. Another x. So everything's going to multiply by x. And now everything's going to multiply by h. This will be x squared h. So I did it like that is because now I have linked together all my like terms. I'm going to add straight down. So I got 1x cubed. I got 3 x squared h. And I got 3 x squared. Then I got an h cubed. That is this. So if you're watching this at home, like I said in class, this is the part where your eyes will glaze over and you start to drift away, wondering, maybe if I go away, somebody else. It looks really messy. This is what I talked about. Stay at class, about setting the tone. Confidence. It's going to look messier when you work with it. Think about like reorganizing your sock drawer, cleaning up your closet, organizing yourself. The first thing you gotta do is lay everything out. It's gonna be messy in the process, but trust the process. Have confidence in yourself because things are going to cancel. Hey, that's exactly what we see. X cubed, negative x cubed, negative x, positive x. So now I canceled away 4 of those terms. Great. What do I have left? X squared h, x squared plus h, all divided by, oh, sorry, got one more, all divided by, okay, now it doesn't look as bad, because things cancel away. Now can I still simplify further? Sure, I see that everything in the numerator is divisible by h, so we can carry out this h, so it's going to say 3x squared plus 3x, one of them, not all of them, plus squared 1 divided by 8. That my final. The order in which you write these terms doesn't matter. 1 first, if you squared first, it doesn't matter. Addition is commutative. What's important is you end up with these 4 terms. Order they're in. Alright, so our last question is number 96. Had to simplify, or sorry, we had to carry out that operation. Actually, I'm going to move this clear space. Go. All right, so now remember from algebra 2, when you divide fractions, it is the same multiplying by the reciprocal second fraction. That is what we're going to do first. Set up, always set up first. That's step 1. Okay, now what? Now I'm multiplying fractions. Okay, well, how does that work? Go and multiply numerator with numerator, denominator with denominator. Again, setup. I'm not going to actually multiply everything together. I'm just going to write the setup. Okay. There. I've done the multiplication. Now, things simplify. Yes, I see the 2's can cancel. X minus 9's can cancel. So you're really left with is just x plus 7, x minus 7. That is your answer. Now, if you make this mistake, I'm prefacing it by saying mistake. If you make this mistake of going, hey, x and x, they cancel too, right, Mr. Sardui? And then it's 7 over negative 7. The answer is negative 1. Right? Wrong. Okay? It's wrong. You cannot cancel individual terms when you are adding or subtracting in a division problem. So no, you cannot do this. This is incorrect. What I circled in red, that is the final answer. Now again, if this were in an assessment, if you showed your steps and then you go on to do this, are you going to get the whole question wrong? No. Would lose some points, but you will get partial credit. Why? Because you showed me. Yeah, you know how to multiply. Yeah, you know how to cancel, but then you don't know how to 100% cancel. So I'm going to take off some points, but you'll earn some credit. But you have to show your work. So if none of this was here, if all you did was just leave me this and say this is equal to negative 1, guess what? You get no points. Why? Because this is wrong, and I have no work to see what you did. So please show your work. Okay? Don't anything out. That's why we're doing it on OneNote. It's beautiful. You have all the paper in the world. It's digital. Right? All right. So those are all of our questions that were submitted via email. And hopefully you found this useful. If you did, please make sure to leave a like on the video, subscribe to the channel.